Good evening, everybody. My name is Ashley Stickles, and part of the group for energy efficient vehicles. So, have you pulled your car up to the gas pump lately and been shocked by the high price gasoline as the pump clicked up to $20, $30, $40, and even $50? Maybe you thought about trading your car for something that gets better gas mileage. Or maybe you're worried that your car is contributing to the greenhouse effect. Well, lucky for you, we have some options for you to consider. I'm going to discuss the hybrid. Okay, a hybrid car is a car that uses two or more forms of power. It is an excellent way to improve upon fuel economy, cut down on pollution, and stay on top of the latest automotive technology. Hybrid cars are far from new. The first hybrid was built over 100 years ago, the Mixte, built by Porsche. It won a car rally, and it used a gasoline engine to power a generator which ran an electric motor. This had dual fuel vehicles, were not uncommon in the 1930s and 40s. Many buses and other heavy transport vehicles had systems which allowed them to run on petrol or diesel. A little more about hybrid. The technology was to power the hybrids of today really began in the 1970s. Victor Walk is usually seen as the godfather of the hybrid car after he developed a hybrid drivetrain for a Buick. Progress stalled when the U.S. EPA ditched the federal Clean Car Incentive Program in the mid-70s. The next technical innovation, which was crucial to modern hybrid design, was a regenerative braking system. It is a harvest electrical energy from the process of braking. This is the energy used to recharge the battery and reduce fuel consumption. David Arthurs developed the first one in the mid-1970s. He was able to reach 78 miles per gallon in a modified Opel GT sports car. The Prius is probably the most well-known hybrid and is deservedly the leader in the field. The Toyota Prius was the brainchild of the engineer, and it went on sale in 1997. Sales of the Prius now total 829,000 vehicles and counting. Here's a video.
The Prius has unique high-tech features that raise the standard in car technology. Smart Entry allows you to enter the car with the smart key still in your pocket or bag. An onboard sensor recognizes the signal from the key and automatically unlocks the doors. Smart Start allows you to start the car by simply pressing the power button located on the dashboard, leaving the smart key in your pocket or bag. The ergonomic cockpit includes a 7-inch touchscreen that centers the control of climate, audio, Bluetooth phone, DVD navigation, and even the energy flow of the hybrid Synergy drive system. The Bluetooth interface allows for wireless connections between the Prius and any Bluetooth-capable phone. It also provides safer and more convenient hands-free use while driving. E-technology replaces mechanical and hydraulic links with electrical connections to reduce weight, save fuel, and reduce emissions, ensuring a safer, immediate, and reliable response. Through the drive-by-wire uphill assist control and motor traction control, grip and safety are maximized in every condition. Drive-by-wire saves fuel and generates more responsive acceleration. With the E-Shift integrated in the dashboard, shift-by-wire offers a better use of space and is extremely smooth and practical. The ECB brake-by-wire simply helps you stop the car more easily and more accurately under all conditions, resulting in shorter braking distances irrespective of load. EV driving mode allows the driver to operate in electric-only mode with zero fuel consumption, zero emissions, and no engine noise.
Okay.
No,
Well, I was going to go to here.
you just have it.
All right. Is everything working? Okay. On to the hybrid cars again. The most common type of hybrid cars combines is diesel and electric power, gas and electric power. What? Oh, biodiesel and electric power. So, the electric motor in a hybrid can also act as, does anybody know? 1, 2, or 3? What is it? Did I hear a generator? All right. Good job. Okay. The typical hybrid cars are electric motor and is more advanced than an ordinary motor. For example, as you accelerate, the motor can pull energy from the batteries to make the car go faster. But when you slow down, it can act as a generator, reducing the recharging batteries. Okay, and the Toyota Prius uses its gas engine to, is anybody, got any guessers? 1, 2, or 3? All right. Did I hear power the car at certain speeds beyond 15 miles per hour? Okay. Give it on to Christian.
The Prius cuts down on the emissions, and it uses the electric motor to get the car going and then to accelerate up to about 15 miles per hour. And then the gas engine takes over. The benefits of a hybrid car include reducing emissions, improving gas mileage, or both A and B. That's right, both A and B. The two main benefits of the hybrid car are cutting down on emissions and improving gas mileage, and they're interwoven. Because you're using less fuel, you're putting out fewer emissions. So the fact that it goes back and forth cuts down. Now we're going to move on to diesel and Mona.
No.
Oh, Josh.
Thank you.
I should know that.
Hello. I'm going to talk about diesel cars. Diesel engines work almost exactly the same as a regular gasoline combustion engine, except they run on diesel fuels. Diesel fuels do not require an igniter. Diesel ignites under pressure. Gasoline engines require a spark plug to ignite, as opposed to pressurized fuel. Diesel vehicles become green when you use a biodiesel fuel instead of regular petrol diesel. Biodiesel is a domestic renewable fuel for diesel engines derived from natural oils like soybean oil, and they meet the specifications of the ASTM D 6751 Act from the EPA. Biodiesel is a clean-burning alternative fuel produced domestically from renewable resources and contains no petroleum. Biodiesel can be blended with petroleum diesel. Biodiesel can be used in most any diesel engine with little to no modifications. However, most manufacturers suggest you only use B5 or lower biodiesel. There are different blends of biodiesel. B100 is 100% biodiesel. B2 is 2% biodiesel, and 98% petrol diesel. And then there's also B5 and B20 blends. B2 and B5 are able to be used in most regular diesel cars without doing any modifications. And using a higher blend can often void your manufacturer's warranty. And here we also have a diagram of how diesel fuel is made from using just regular vegetable oil. A lot of times you can go to fast food restaurants and get used oil for free and then convert it to this using this process. A lot of people do it in their homes even. And here is a little video about making the biodiesel.
One of the problems with alternative fuels for our vehicles is they often can't be used in conventional engines. But biodiesel has fast become a standout in the alternative fuel world because in most cases it can be used in existing diesel engines. Biodiesel is diesel fuel that has been manufactured from new or used vegetable oils instead of petroleum. It burns cleaner with fewer emissions and usually comes from soybeans. In today's market, biodiesel is often blended with conventional diesel. B20, a blend that uses 20% biodiesel, is most common and can be used in almost any conventional diesel engine. Blends over 20% and even pure biodiesel, or B100, can also be found. However, there are some concerns about engine wear and its ability to work in colder climates. With more time and testing, we may see the acceptance of blends that use more biofuel. Either way, blends still reduce the need for petroleum-based diesel. If you're worried about not being able to find it when you need it, check out nearbio.com. Their free service sends the location of the nearest biodiesel retailer directly to your cell phone, so it's with you wherever you go.
This one? No. Okay. The NBB, the National Biodiesel Board, provides a list of auto manufacturers, which I've provided you, that produce diesel cars, as well as their warranty position on using biodiesels. Audi, BMW, Chrysler, Ford, and General Motors, Mercedes-Benz, and Volkswagen all approve up to B5 in their passenger vehicles. You can use higher, but sometimes the engine components can degrade while using higher levels of biodiesels. Also, using biodiesel 100 in colder weather can solidify easier than petrol fuels because it's made of fatty oils. In 2009, Green Car Journal named the 2009 Volkswagen Jetta TDI the Green Car of the Year. Green Car Journal described the Jetta as fuel efficient, affordable, fun, and clean. It meets the emissions regulations of all 50 states, and it has very low greenhouse gas emissions, as well as can achieve higher than 41 miles per gallon on the highway and 30 miles per gallon in the city. It still provides plenty of torque and a satisfying driving experience.
Hey, Max. New car, huh?
Yeah, the Jetta TDI Clean Diesel.
I got a hybrid, so, you know.
A TDI set a Guinness World Record 58 miles per gallon.
58 miles per gallon?
But this baby hauls! It's like... What's your hybrid sound like? That's cool.
Okay, and here is a list of stations here around the area where you can buy biodiesel. These are only 4 of 151 that we found in Illinois.
Hi, I'm Mona. I'm going to be discussing the hydrogen fuel cell cars. The hydrogen fuel cell, these cells use hydrogen gas and air to create an electrical current to power a vehicle with only water as a byproduct. In 1807, Francois Isaac de Rivaz of Switzerland designed the first international combustion engine that ran inside the first automobile. This first experimental prototype was powered by hydrogen gas and oxygen. The Rivaz car stored compressed hydrogen gas in a balloon, and it had an electrical volta-cell ignition. In 2003, President Bush announced a program called the Hydrogen Fuel Initiative during his State of the Union address. This initiative, supported by legislation in the Energy Policy Act of 2005 and the Advanced Energy Initiative of 2006, aims to develop hydrogen fuel cells and infrastructure technologies to make fuel cell vehicles practical and cost-effective by 2020. The United States has dedicated more than $1 billion to fuel cell research and development so far. And here is a little video.
Hi, I'm Ron Kogan with greencar.com. Today we're going to talk about how fuel cells work. You know, most people don't understand a fuel cell is a lot like a battery. It creates electricity. That electricity is used to power drive wheels. Differing from a battery, however, is that a fuel cell doesn't need to be recharged. It receives a continual flow of fuel, so it always produces electricity as long as that flow continues. That's an important distinction. Batteries are heavy, they're bulky, they take up a lot of room. In an electric car, your range is dictated by how much battery power is on board. In a fuel cell vehicle, the hydrogen fuel cell stays the same size. Range is only dictated by how much fuel you can carry on board. And that's a big deal because in the end, fuel cell vehicles will have the same driving range as conventional vehicles. A lot is being done in the storage of hydrogen fuel to accommodate that. Hydrogen fuel cell takes in oxygen and it takes in hydrogen. It's introduced into the fuel cell. Inside are two electrodes and an electrolyte. The hydrogen goes through one path, the oxygen goes through another path. They combine at the end to create water, H2O. You have little water drips. That's your exhaust emissions, which is wonderful. During the process, they create electricity. That's the magic. That electricity is made in abundance to power drive motors on board. It gives you efficient transportation, zero-emission transportation, and it frees you from dependence on imported oil.
According to Honda, their FCX Clarity zero-emission hydrogen fuel cell cars run on electricity by means of a fuel cell that contains hydrogen and oxygen. When they mix, electricity is produced, only water is left. The FCX Clarity FCEV does not use any gasoline at all. It runs on clean, domestically produced compressed hydrogen gas. Hydrogen is the most abundant element in the universe. And here's another video.
Though it may look and sound like something from a science fiction movie, the 2009 Honda FCX Clarity is all fact. The green, fuel-efficient, and petroleum-free future is here. But you have to lay down some green to go green. The FCX fuel cell vehicle will only be available as a 3-year lease at $600 per month. And the car will only be available to Southern California residents who live near existing hydrogen fuel pump facilities. Honda unveiled this fuel cell car at the 2007 Los Angeles Auto Show and gave us the chance to drive one a few days later. We're happy to report the FCX Clarity is a full-functioning Honda. It's well-balanced and easy to drive. And it's comfortable almost to the point of being luxurious. Honda says that the electric motor delivers the equivalent of 134 horsepower and will propel the midsize sedan from 0 to 60 in about 9.2 seconds. That's the same time we recorded for a 2008 Honda Accord sedan with a gasoline-powered inline-4. We weren't able to test Honda's claim that the Clarity can achieve 100 miles per hour, but given our experience driving it on the highway, we believe them. The FCX fuel cell produces electricity to power the vehicle's electric motor. The entire power plant is 397 pounds lighter and 45% smaller than the system in the previous generation FCX. It achieves the equivalent of 68 miles per gallon from its hydrogen fuel cell. Since a kilogram of gaseous hydrogen fuel is roughly equivalent to a gallon of gas, Honda's 4.2 kilogram tank delivers a cruising range of 270 miles with 0.2 kilograms of fuel in reserve. Freed from the constraints of a bulky gas engine and transmission, the FCX Clarity has a striking exterior design, featuring an extremely short nose with a steeply raked A-pillar. The long glassed-in cabin is made even more dramatic by powerful fender and character lines. The interior is light, bright, and futuristic. Keeping with the green theme, the upholstery for the seats, door panels, flooring, and ceiling is recyclable. Honda developed petroleum-free fabrics made from corn. Honda won't disclose how many of the new cars it intends to build, but we expect it to be somewhere between 100 and 200. Real people will get some, but don't be surprised to see more than a few celebrities driving around in a 2009 Honda FCX Clarity. If environmentally sensible advanced technology vehicles are ever to go mainstream, they have to be accepted by all the working stiffs who share those 5-mile-per-hour morning commutes.
Okay. Creating an infrastructure of hydrogen fueling stations has been an obstacle to the manufacture of hydrogen-powered cars. Honda also announced progress with a home-based hydrogen production system called the HES-IV that would remove a consumer's need to find hydrogen fuel or visit a gas station. The company installed such a system at its headquarters in Torrance, California. The system was created by Honda and Plug Power Incorporated, a provider of on-site energy solutions. Before fuel cell vehicles can have any significant market penetration, there will need to be a viable solution to the inevitable refueling question, said Mark Sperry, Chief Marketing Officer at Plug Power. The home energy station provides the means for vehicle owners to produce on-site hydrogen as well as heat and power in an efficient and environmentally friendly way. 70% smaller than the first generation version, the HES-IV makes use of a home's existing natural gas supply in order to produce hydrogen for vehicles, as well as providing heat and electricity for the residents. Honda claims that using the HES-IV to heat a home and fuel an FCX Clarity would reduce CO2 emissions by as much as 30%, compared to the conventional usage of grid-supplied electricity and gas-powered automobiles. Energy costs would also be lowered by an estimated 50%. Availability of the in-home system is not expected for another 7 to 10 years. And next we have zero emissions.
Okay. The zero emissions vehicles, or ZEVs, has zero tailpipe emissions and emits 98% cleaner emissions than its current model year's average vehicle. Electric vehicles and fuel cell vehicles qualify as ZEVs. Zero-emission vehicles run the gamut across the entire board of the green cars because a requirement for a zero-emission car is only that there's no emissions. It can be any type of car, such as a hydrogen fuel cell, a hybrid electric car, a Segway, or a bicycle. No emissions from a bicycle. Okay, there's pros and cons, and we'll go over the pros first. There is no gas. No gas means no carbon footprint, no costly trips to the pump, no oil changes, and less of a dent in your wallet. By driving an electric car, you can educate others, and people show interest usually in your hybrid or your electric car and want to know. And so, and depending on how much you drive, you may save money when compared to a gas car. The cons are you can only go so far on a charge, and it takes time to charge the car. It takes 6 to 8 hours usually, and longer if it's just a regular 120 volt, but it just depends. Customer support is limited from the manufacturers. Sometimes, depending on the car, obviously not on the newer cars, but there are electric car kits that you can get and stuff like that. So if you go that route, you'd have to be willing to learn about how your car works and be able to do some of the repairs yourself. Obviously, for the newer ones, you know, that are coming out, you would have more manufacturer support, but as you saw, there's usually a limited number of those. Insurance can also be hard to find, and financing can be difficult, and they're much more expensive usually than a regular car. Okay, Nissan Leaf is the newest in the zero emissions electric car. It's going to come out at the end of 2010. It's 100% electric. It burns zero gas and zero emissions. And one of the things that they want to point out is that it's not a golf cart. It performs like a V6. There's room for 5, and it comes with all the quality, reliability, and versatility that you've come to expect from Nissan. It speeds up to 90 miles per hour, 5 passengers, 5 doors, and all the other bells and whistles that come with cars. Here's another video. We're using the videos to be able to let you see the car, you know, and actually kind of experience it a little.
Nissan on Sunday took the wraps off what it calls the world's first affordable zero-emission car. The all-electric Nissan Leaf will go on sale in Japan, North America and Europe late next year. It seats 5 adults and has a range of more than 160 kilometers, that's 100 miles, on a full charge, and a top speed of around 140 kilometers or 90 miles per hour. Providing power is a bank of lithium-ion batteries developed by Nissan and computer maker NEC. The cells are flat and thin laminated types, and 4 of them are packaged together in a battery pack. Nissan has devoted a lot of research into safety, ensuring they won't overheat or catch fire, especially during an accident. A full charge of the batteries on a standard home electrical socket will take around 8 hours in Europe, but around 16 hours on the lower voltage Japan and US supply. Owners in those countries should be able to get higher voltage sockets installed to help with charging. A quick charge station, like this prototype, will be able to replenish the batteries in around 30 minutes, and Nissan envisages an eventual network of the chargers throughout cities. An important IT feature of the car will be a constant connection to Nissan's data center, over which information and entertainment will be delivered to the car. The car's navigation display will also show the reachable distance, based on driving conditions and battery level, and nearby charging stations. Owners will also be able to control the air conditioning and charging of the cars via mobile phone. This could be used, for example, to make use of a charging center's power supply and run the initial air conditioner blast before driving away, thus conserving battery energy. Last week, Nissan showed a prototype of the system running on an iPhone. In Tokyo, this is Martin Williams, IDG News Service.
I do want to point out, he said the 16 hours, and that is when you plug it into an existing plug in your home. You can also get a different kind of plug, or like what your dryer is plugged into, is it 220 volt? And then that's when you get like an 8 hour. And then of course the goal is to have those quick fueling stations like at shopping centers and stuff, so you could go to work and then you could go do some errands, and while you're doing your groceries or shopping you could plug your car in, and when your car is done charging it'll text you, be like, you know, here I am, I'm ready, and then you can go out there when you're all done. So. Okay, so here's our comparisons between the 4 vehicles. We each picked one main vehicle to show you. We've got the different costs of ownership. You know, the Volkswagen is $22,660. The Clarity is only leased, $600. The Leaf is going to be about $28,000 to $35,000, but then there's also the lease of the battery. So it's very unclear as exactly how much that's going to cost, but they do promise that between the car and the battery that it's going to be less than a gas-powered car. And then the Toyota Prius at $2,200. Or 22,000. Oh, 2,200. That'd be my pick, huh? So, after what you've seen, do you have any questions? What are your thoughts? You know, if you had to pick one, does anybody go, "Ooh, I really want that now," or what do you guys think?
Questions. I have a question to start with.
Yes.
First, we heard about who killed the electric car a couple of weeks ago.
Mm-hmm.
And from what we saw in that movie, that General Motors killed it or had to kill it. Now, I see more electric cars now coming, and 3 of them, of the one that you chose, are Japanese. Any comment on that?
I do. Does anybody else? You want me to take it?
Yeah.
Okay. Okay, first of all, I did find some other research about the whole electric car. The problem with these hybrid electric hydrogen is that you have to have an infrastructure built. You know, you can't just go anywhere and fill up your car with hydrogen. You know, we don't have that kind of technology in place, and it costs billions of dollars to do that. So some of what I read was that the different dealerships were forced into making a car before it was really ready. As you see, the one home station isn't going to really be ready for another 7 to 10 years. So everybody is very concerned, and they should be concerned about, you know, greenhouse gases and emissions. But it does take a lot of money and a lot of other things besides having the car that can go on electricity. So it's not necessarily that they killed the electric car, but it's a slow progression, I think, that needs to be made. You know, everybody, and especially in California, there's a, you know, and we don't live in California, but there's the bigger push because of the whole, you know, their environment's pretty bad. So, and they have a lot of these hydrogen fueling stations. That was the most that we found. There is one hydrogen fueling station here in Illinois. It's in Des Plaines, Illinois, but it's private access. I think to answer your question about, you know, why are there Japanese, you know, kind of pushing it, this is all like a new technology that everybody wants to switch to. And they're trying their hardest to try and get it out there. And I think part of the reason why, like Nissan and some of the other, you know, in Japan are making a push is because they see that in 7 to 10 years, the U.S. and other places are going to be ready. And so if they can get a jump start now and get their product out, then they have a better chance of being able to corner the market and, you know, really be able to, you know, perhaps be a monopoly. I mean, not necessarily a monopoly, but, you know, if they start now, by the time we're ready, the FCX Clarity and the Leaf, those cars will be on everybody's tongue, and, you know, those are the ones that they're going to go for. So,
thank you. Thank you. Any other questions? I have another question.
Okay.
One of your slides showed kind of a map where the stations of recharging would be located or something, like infrastructure or something.
Do you want to see it again?
If it's handy. My question is, now with the system we have now with the gas stations, you are driving from point A to point B, and in between you decided to go to point C to see something or do something else. You don't worry about how much energy you have because you can refill. I mean, you can just, any gas station. With this system, is there any fear that if you are deciding to go from point A to point B, you have a certain amount of energy, you are not allowed, you cannot risk and go on the side track for any reason. You must go to reach your, is there any fear of that?
Well, see, that's part of why the electric car was killed, is because we don't have this in place. Sorry. As you see, these are, you know, proposed fueling stations. None of these are really in existence at all. And that's the problem, is because with an electric car, you can only get about 100 miles. And some of the, you know, the electric and the hydrogen fuel cell is about 270. And so if I want to have a hydrogen cell car in Illinois, well, I get the car 270 miles and then it's dead, and I have nothing to do then. I mean, it's, you know, in California you have a little bit of more range, but it's still not where it's supposed to be. So that is, they call it range, it's in my paper, range anxiety. And that's part of the fear, and that's why if you see in the Leaf, which was the last totally electric car, they have the whole map. And it'll show you the radius of where you can go and where you can't. And so it kind of keeps track of your range for you so that you don't have to worry about, okay, you get 100 miles away from your house and then it's going to die. You know, because, so that's how they've kind of fixed that in the Leaf. But then, yes, I mean, this is the proposal to try and get this across the country so that, you know, if in 10 years we want to go from Illinois to Texas in our hydrogen car, you know, we can drive 270 miles, stop, refuel, and then keep going. Or also on our electric car, I mean, it'd take a little bit longer to get there, but, you know, go 100 miles, charge it up for 30 minutes, and go 100 more. So.
Now, just to make sure myself know that I'm understand correctly, these dots are not connected per a hard connection. It is just a location, like gas stations. And the lines between them are just routes. There are no pipes or cables between these, right?
As far as I know, yeah, they'd be locations.
Okay, okay, great. Any other questions? Yes,
What would be the cost of refueling with hydrogen?
With hydrogen. Hold this for a minute. They all vary. I'm trying to look real quick for you, and I should know, and I'm sorry.
I think it was about roughly between $3 and $5 per what would be a gallon. So it is at the moment more expensive.
But you do 41 miles per gallon.
68.
Or 68.
68 miles per gallon. It is.
A gallon of this makes maybe 3 gallons of the other type.
Yes.
Today you have 2.5 per gallon, so 3 gallons makes 7.
And eventually it would be less expensive with increased production and popularity. So likewise with the biodiesel, and diesel cars go further on a tank than even regular cars. Biodiesel is relatively expensive now to produce unless you make it at home using recycled vegetable oil. If you go and get it free from, say, McDonald's, and then you could put that in your car once you processed it. But it's relatively expensive to produce if you're a manufacturer.
Any other questions? Thank you very much.
Good evening, everybody. My name is Ashley Stickles, and I'm part of the group for energy efficient vehicles. So, have you pulled your car up to the gas pump lately and been shocked by the high price gasoline as the pump clicked up to $20, $30, $40, and even $50? Maybe you thought about trading your car for something that gets better gas mileage. Or maybe you're worried that your car is contributing to the greenhouse effect. Well, lucky for you, we have some options for you to consider. I'm going to discuss the hybrid. Okay, a hybrid car is a car that uses 2 or more forms of power. It is an excellent way to improve
with electrical connections to reduce weight, save fuel, and reduce emissions, ensuring a safer, immediate, and reliable response. Through the drive-by-wire uphill assist control and motor traction control, grip and safety are maximized in every condition. Drive-by-wire saves fuel and generates more responsive acceleration. With the E-Shift integrated in the dashboard, shift-by-wire offers a better use of space and is extremely smooth and practical. The ECB brake-by-wire simply helps you stop the car more easily and more accurately under all conditions, resulting in shorter braking distances irrespective of load. EV driving mode allows the driver to operate in electric-only mode with 0 fuel consumption, 0 emissions, and no engine noise.
Okay. Upon fuel economy. Cut down on pollution and stay on top of the latest automotive technology. Hybrid cars are far from new. The first hybrid was built over 100 years ago, the Mixte, built by Porsche. It won a car rally, and it used a gasoline engine to power a generator which ran an electric motor. This had dual fuel vehicles, were not uncommon in the 1930s and 40s. Many buses and other heavy transport vehicles had systems which allowed them to run on petrol or diesel. A little more about hybrid. The technology was to power the hybrids of today really began in the 1970s. Victor Walk is usually seen as the godfather of the hybrid car after he developed a hybrid drivetrain for a Buick. Progress stalled. Video.
The Prius has unique high-tech features that raise the standard in car technology. Smart Entry allows you to enter the car with the smart key still in your pocket or bag. An onboard sensor recognizes the signal from the key and automatically unlocks the doors. Smart Start allows you to start the car by simply pressing the power button located on the dashboard, leaving the smart key in your pocket or bag. The ergonomic cockpit includes a 7-inch touchscreen that centers the control of climate, audio, Bluetooth phone, DVD navigation, and even the energy flow of the hybrid Synergy drive system. The Bluetooth interface allows for wireless connections between the Prius and any Bluetooth-capable phone. It also provides safer and more convenient hands-free use while driving. E-technology replaces mechanical and hydraulic links.
When the U.S. EPA ditched the federal Clean Car Incentive Program in the mid-70s. The next technical innovation, which was crucial to modern hybrid design, was a regenerative braking system. It is a harvest electrical energy from the process of braking. This is the energy used to recharge the battery and reduce fuel consumption. David Arthurs developed the first one in the mid-1970s. He was able to reach 78 miles per gallon in a modified Opel GT sports car. The Prius is probably the most well-known hybrid and is deservedly the leader in the field. The Toyota Prius was the brainchild of the engineer, and it went on sale in 1997. Sales of the Prius now total 829,000 vehicles and counting. Here's a